Need an alien check. Anyways, I thought if this was a tweet up, I shouldn't give a talk without tweeting. So I'm about to submit a tweet. The solar system. Asteroids, comets, planets, and moons. A 3D billiard ballet choreographed by the forces of gravity. Tweet. We heard that at the end of the GRAIL mission, what did you say? They will be deorbited? Was that your comment? That's code for crash landing on the lunar surface. But let us not be fooled by this language. I'm really here to tie a bow on this afternoon. You've been here quite some time in those seats. And I didn't build the spacecraft. I'm not launching it. I'm not the PI. I'm here to reflect on what it is to actually engage in this kind of enterprise. And the way I want to do that is to remind us of how limited our view of the world is. We have our traditional 5 senses. We can recite them. We probably have more senses than that, but let's go for the big 5, right? There's your sense of sight, smell, touch, taste, and hearing, right? The most useful of those in the universe is our sense of sight. That gets you information from farther away than anything else. Of course, probably the least useful in the universe is your sense of taste. You can't taste a black hole. You wouldn't want to do that anyway. I'm just saying. Now, we might have other senses. For example, our sense of balance. You know, there are other things you might add into that 5, but those are the big 5. All right, now, if we look at our sense of smell and sense of taste, our trajectory through the tree of life tells us that if we see a rotting, vermin-infested corpse, we want to walk away from that. It smells bad to us. It tastes bad to us. It'll make you sick. Whereas vultures, hyenas, there's a whole part of the animal kingdom for whom that smells like hors d'oeuvres from a fine restaurant. So their senses are bringing a different picture of the world to them than our senses bring to us. Now, it was not until we were in a position as a species to replace our senses with tools that are not susceptible to what your brain does to the signals that your senses receive from the natural world. It was not until then that we could claim that science was born. Modern science. That's traceable basically to early 1600s. Galileo, among others. That's the invention, at that time, the invention of the telescope. Just a couple of years after the invention of the microscope. These are tools that take us places that our senses can't, that allow us to measure things without the susceptibility of the human brain getting in the way. We like to praise our brain as being a powerful organ. We like to praise our sight as being an extraordinary device, the human eye. However, what we learned in the discoveries of the methods and tools of science is that our sensory system is not only feeble, it deceives us. You cannot claim to understand the universe through sensory devices where half the time they're giving you the wrong information or allowing you to interpret it the wrong way. And what do I mean by wrong? It's because you get a different result than somebody else does. It smells different to you than to the carrion smells different to you. The sunset looks different to you than it does to insects. Insects, most flying insects, see ultraviolet light. We cannot. They have much more beautiful sunsets than we do. By the way, evidence that we are smarter than insects is that we can devise tools to kill them, exploiting this fact that they see ultraviolet. Who here has seen, owned, or observed bug zappers? What is the color of the light inside the bug zapper?
Blue.
It's blue. And what attracts them is not even the blue, it's actually giving off some ultraviolet. They can't help it, they fly into it. They get zapped. In fact, their entire sensitivity to light is shifted towards the blue, towards the violet, to the point where they can't see red or orange. So there's another kind of bulb, which used to be common, called a bug bulb. That's an orange bulb. You put it over your picnic table. People used to think that it repelled bugs. No. What does it do? Nothing. Bugs can't see it. They don't even know it's there. So unless they're coming to your food, they're certainly not attracted to that light. So we've exploited this intelligence that we have about bugs. More evidence that we're smarter than cats. I heard a comedian joke about this. Evidence that we're smarter than cats because we're not afraid of vacuum cleaners, right? We need to be reminded of our intelligence every now and then. The point is that our senses are not the whole story. The simplest variant on this is that visible light, famously labeled Roy G. Biv, red, orange, yellow, green, blue, indigo, violet. Newton put the indigo in there. It doesn't really belong. If you're going to divide up the spectrum that finely and call something indigo there are 10 other colors you could have also added. Okay? But Newton was a big fan of the numeral 7. He had some mystical, magical feelings about 7. So there's red, orange, yellow, green, blue, violet. Had to throw in a 7th color, hence indigo. Okay? There you have it. But it spells Roy G. Biv. Fine. I'm okay with that. We build telescopes to observe in these wavelengths of light. We look up into the cosmos. It was not until the 19th century that we had any clue that other bands of light were available to us. The universe was speaking to us outside our ability to detect it. The universe was sending us ultraviolet, infrared. Let's go in one direction. Red, orange, yellow, green, blue, violet, ultraviolet, X-rays, gamma rays. This is all part of the electromagnetic spectrum of light. It all travels the speed of light. And the universe is talking to us in each one of these bands of light. You go the other way, red, infrared, microwaves, radio waves. That's the part of the spectrum headed off in the other direction. The 19th and 20th century, one of the unheralded advances of these 2 centuries is our ability to not only know these bands of light are there, but to exploit them with the methods and tools of engineering and of science. We don't have detectors for ultraviolet. Well, you sort of do. It's your skin, and by the time you know you've been exposed to ultraviolet, it's a little too late, okay? These are time-delayed detectors, if you want to call it that. How about X-rays, gamma rays? We sort of have gamma ray detectors. It's when your arm falls off, right? That's, oh, I was exposed to gamma rays earlier. Old-timers here might remember, if you ever worked around radioactive materials, you had a radiation badge. You know what that was? It was film. Oh, there's some younger people here. Film is this thing. It was made of plastic and it had like a silver, it had some chemical on it. Some chemical on it that could detect, okay. I needed that explanation. So it was a badge, and there were different thicknesses of lead pellets sitting above it. And so at the end of the day, you take it in, they would develop the film, and then inform you later on whether or not you're sterile, okay? So, we sort of have detectors for these things, but they're not useful detectors to us. Infrared, you can't see it. Your skin senses it as heat. Microwave, we have no microwave detectors at all. It's all based now on your cell phones. If you could see microwaves, everyone on a cell phone, this would be ablaze with light. It would be passing through the walls. If you could see microwaves, you tune to that, all these walls would be transparent. you'd accidentally be walking into them the way we walk into windows, which are themselves transparent to visible light. So, the transparency of something is really just what kind of wavelength of light are you using. That also applies to the universe. The universe is most transparent to radio waves, because other bands of light get obscured by dust clouds and other interstellar phenomena that simply gets in the way. So it was not until we had radio telescopes that we could peer deep into the center of the galaxy. It wasn't until we had ultraviolet telescopes and X-ray telescopes that we could find black holes. Books published in the 1950s and 60s talked about the clockwork universe, the universe, the beautiful, serene universe. That's our bias kicking in. We were only viewing the universe in optical light, visible light. Once you had the X-ray telescope and the gamma ray telescope and the ultraviolet telescope, you begin to see explosions going on in the centers of galaxies, collisions of stars and galaxies. Textbooks published started calling it the violent universe. A dangerous place out there. Now, if we look at our senses, if our senses define your life and your expectations, I could take this ball and I let go of it. So embedded we are in our senses that the very statement, let go, means drop it. When in space, if you just let go, you let go and it's still floating. Let go means something different in space than it does here on Earth. So once again, your life experience is influencing how you're interacting with the world. So, if you now look at the frontier of cosmic discovery, until the 1900s, you could judge a physical law based on whether or not it made sense to you. You could do that. That doesn't make sense. It can't be true. What happens in 1900? The quantum is discovered. 1905, relativity is advanced by Einstein. 1916, general relativity is published. 1920s, we discover the expanding universe. Hubble, the man. He was a person before he was a telescope. Yes, he did. She was aware that Edwin Hubble was a basketball player. He also had an affected British accent, and which some Americans do because they're embarrassed by their own accent. Plus, he was also a racist and a misogynist. How do you like that? Yet we can still praise him for his scientific discoveries. This is the interesting thing about science. If you get it right, it transcends even who you are. So, as the weirdness of the universe is laid bare by these new understandings of the quantum, the physics of the small, and general relativity, the physics of the large, all of a sudden, we are probing the world in regimes outside of anything your senses possibly saw in your entire life. So now I can tell you, particles pop in and out of existence. The whole universe is expanding and was once smaller than the head of a pin. And you say to yourself, that doesn't make sense. Of course it doesn't make sense to you. It doesn't issue forth from your five senses. And that is what defines within us what makes sense. If I dropped this and it fell to the ceiling, you would say that doesn't make sense. But in a quantum universe, that happens 20% of the time. If we were the size of a quantum, stuff would be happening. People would pop in through the wall, out the wall, and you say, oh, hey, Joe, you know. It's like, look, you wouldn't even, it would not even be an issue to you because of your life experience. If we were the size of the quantum, E equals mc squared would not have required Einstein to deduce because we would have seen that formula manifest daily in front of our eyes. So we live in a time where it is no longer sensible to require that a theory of the universe makes sense. All that matters is that it's consistent with the data. And those theories of the universe and those observations that we come up with, they come from methods that not only extend our senses, but bring in whole other categories of sensory readings of the world around us. The spectrum is a natural understanding of an extension of our senses, not only in wavelength, but in sensitivity. That's one. There are other senses we don't have. We don't have magnetic field detectors within us. We are magnetic field blind. We got tools for that. I got an app for that, right? All right. You can't detect, there's an obscure property of light called polarization. Our eye cannot detect the polarization of light. You can if you had Polaroid sunglasses. You can do this experiment. But without them, your human physiology cannot accomplish this. You know what else you can't accomplish? You can't detect changes, subtle changes in gravitational field. You can't. If this part of the room, the gravity vector, were not parallel to here, I would walk over here and then I'd be leaning and I wouldn't even know I was leaning. In fact, evidence that that's the case is why people in Australia don't know they're upside down. Nobody told them. Because you just walk around on Earth, slowly the gravity vector is switching, and you're switching with the gravity vector. And then you come around the backside, you are upside down and you don't even know it. So here we are. We're trying to probe the moon. The surface is easy. We've been there. More places on the surface to observe, but we got an understanding of the surface. But the surface has revealed elements about the moon that require knowledge of what was going on beneath it, that we don't yet have. Now you can't X-ray the moon. X-ray has some penetration depth, not enough. You gotta be cleverer than that. So what you have clever PIs, you have clever engineers who say, let's find the gravity vectors of the moon. If gravity's a little stronger here than there, maybe it's a little more dense over there. There's a little more material between this object and the center of the moon over here than over here. If you do this continuously, you can map the gravitational structure of the moon and infer the mass profile of what's going on down into its center. That is building a machine that is beyond our senses, decoding the universe for us and bringing it to us on a silver platter. So, NASA has been all about extending our senses. And once you have a well-designed experiment, then it's the results of that experiment that you then must contend with and deduce what it forces you to think. This gravity measurement that has been going on, oil companies use them. Why? What are they looking for? Oil, yes, okay. It's not a trick question. I ask simple questions here. Oil, they're looking for oil. Oil is less dense than rock. Okay? Heavy, thick, sludgy oil is less dense than water. That's why oil floats. Heavy, thick whipping cream is lighter than skim milk. That's why it floats. I gotta tell you real quick, I was in a little coffee shop in Pasadena. I don't even like coffee, I had hot chocolate. And the only way to have hot chocolate is with a dollop of whipped cream. So I ordered my hot chocolate with whipped cream. I didn't see any trace of whipped cream on the top. I said, I ordered this with whipped cream. He said, oh, we already put it on. I said, well, where is it? He said, oh, it's sunk to the bottom. All the people you're going to tell that to, I am the wrong one to make that statement. I felt like, Clint Eastwood or something. This is I said, excuse me, either the laws of physics of the universe are different in your coffee shop, or you did not put cream on this coffee, because the cream would float. And he said, no, it sinks. I said, just go back, put the cream on, and let's do the experiment together. Gets the cream, puts the cream in, and it bobs that one and pops up, floats. He said, wow, look at that! I'm like, how else do you think skim milk got its name? You skimmed the cream, the heavy, thick cream, off the top. And if you float, it means you are lighter than the stuff below, technically less dense. My point of all this, that was a long aside. I'm sorry. I know you guys are hungry. I'm sorry. I'm sitting here for 5 hours. So the point is, we've been thinking about gravity for a while. One of the most fertile places to look for oil is the Gulf. Sorry, our Gulf, any Gulf, probably, but there's the Persian Gulf, and then there's the Gulf of Mexico. Oil companies are all throughout there. You go down there, Galveston, Texas, you see oil rigs out there in the Gulf. There was a measurement made, a gravimetric measurement made of the Gulf region. The Gulf is enclosed by, from your view, you have Mexico coming down and hooking under before you get to the various islands of the Caribbean. They found gravity anomalies in the Gulf. They started tracking them, and it formed a ridge buried beneath the sands. There was a ridge of concentrated material. And so they followed the ridge, and it made a circle 150 miles across. And they said, oh, how do you get a circle that big of distorted landmass? They went down there to get a date for when that circle was made. 65 million years ago, that circle was laid down just off the Yucatan Peninsula in the Gulf of Mexico. What else happened 65 million years ago? That was a high-pitched dinosaur. Yeah, he said dinosaur. Say that on the microphone so all of NASA TV can hear you.
Dinosaur.
Oh. Her octave range there. So we found the smoking gun, the crater that was laid at the time the dinosaurs went extinct by gravimetric measurements made by oil companies searching for oil. We define who and what we are as a culture by our power to see the world in ways where our senses are left way behind. Period. People say seeing is believing. No, it's not. What are these books we have? Optical illusion books? We call them optical illusions. Is that really what we should call them? I don't think so. We should call them brain failures. Because that's what they are. Simple line drawing. Is it in the page? Out of the page? I can't figure it out! Oh, what is that? I don't know. Brain failures. A failure of your sensory system to understand what you're looking at. Period. So every time someone comes running forth, tells me they saw something, therefore it must be as they saw it. I said, I'm sorry, it's not good enough. Could be a UFO, could be, even if they like hung out with aliens. You come back the next day, drag the alien with you, okay? I don't care, put that on the floor, then we can have that conversation. Your senses are not useful to me. They're just not. And so I celebrate the legacy of NASA, the legacy of its science missions, the legacy of what it is to explore, going where no one has gone before, relying not only on what an astronaut tells you, but on images and on chart recorders and on every possible way you can probe what it is you don't otherwise understand. Because therein is the power of what it is to explore armed with the methods and tools of science, enabled by the creativity of engineers. That is this marriage that has existed ever since the beginning of the birth of science. And I made a little note of, just see if I covered all my things here. One changes tape. That tape is on there. Let's see, your first class. Yeah, good. Got that. Oh yeah. All right. Shouldn't you guys have all like been at work today? Is the unemployment rate that high? You all like playing hooky today, is that right? Oh, okay. Who here is actually not playing hooky because you actually don't have a job and you're looking for a job? Okay, so this is a marvelous thing to do when you're unemployed, except it costs you because like you paid to come down here. But I think this is like an adult field trip. Research in education has shown that children, when they go on field trips, they remember them long into adulthood. Every one of us remembers trips you went on in 2nd grade, 3rd grade, even if you don't remember the teacher or anything, other details, you remember you went on that trip and what you visited. And my fear is that not enough of that happens in adulthood. We become jaded. We forget what it is to ask questions and to explore. We become, I think we, well, she said we get pathetic. I was trying to be a little more poetic. Well, no, she said apathetic. No, okay, so we become pathetic. Speak for yourself. I'm going to finish up in a minute here. Just in terms of what it is, a scientist is someone who actually just never grew up. That's really what a scientist is. We spend a year teaching children that are freshly born, the first 2 years of their life, we teach them how to walk and talk. We spend the rest of their lives telling them to shut up and sit down. This is how we interact. The kid wants to jump 2 feet into a mud puddle. You say, no, don't do that. You'll get your shoes dirty. You'll get your clothing dirty. You've just removed the possibility of an experiment in cratering. Just saying. Anyhow, so let me close out. You guys are on a frontier, an experiment really that NASA is conducting to disseminate the love and the science and the vision and the mission, not only the missions but the mission statements to the broader public through social media. And it was an honor to address you guys because you're not just regular folk. You're tweeps. I'm sure there's a universe where that is such an insult. Right? You tweet, you know, so here it is a badge of honor, and you're certainly wearing them all now. Have a good night, and we'll see you tomorrow.